Welcome everyone to the AQR Unit 2B Reteach. Hopefully you have your paper that goes along with this lesson. We're going to start with question number 1. Our first question of the day has to do with weighted diagrams. So we're going to make a tree diagram and we're going to look at different percentage weights. So in this question we see a portion of a restaurant's menu is shown below. For the low price of $8.99, you get to choose one item from each category. The managers wanted to know how often each item was ordered, so every time this special was ordered, the waitstaff kept track of the item that was chosen. Results are displayed in percents. So we have appetizers of onion rings, fried mozzarella, chips and queso, chicken tenders and fries, cheeseburger and fries, chocolate mousse, apple pie a la mode, chocolate brownie with ice cream. These are all the different choices. You see the little numbers next to them. Those are actually percents. So what we wanted to do first, they said to make a tree diagram. So I'm going to get to a blank space and we can start drawing our tree diagram. What's different about this diagram compared to other diagrams is that it's going to have little numbers on it. So if you followed us through the Unit 2A reteach, we did the same kind of diagram. We just put little branches, but before we had no numbers. So I'm going to abbreviate here so that I don't end up using the entire sheet of paper for this. So start with the appetizers. We've got OR for onion rings, FM for fried mozzarella, CQ for chips and queso. What we want to do is put our little percentages on here, and we're going to put them in decimal form. 0.35 for 35%. 0.42 for 42%, and 0.23 for 23%. What you will notice about each little section is that these percents add up to be 100. Or if you add these in decimal form, they add up to be 1. So whenever we go to our next little group, this time we have chicken tenders and cheeseburgers. So chicken tenders, cheeseburgers, and chicken tenders has a 38% or 0.38, and then cheeseburgers have a 0.62. So again, if you add these numbers together, you end up with a 1. Through the magic of recording, I've gone ahead and filled those in, so now we have all of our second set of branches written for the entrees. Then we're left with doing desserts. So there are 3 different desserts, so we need 3 branches coming off of each of these different entree items. And this time we're going to end up with things like chocolate mousse, apple pie, just use A there, and then we've got chocolate brownies, so I'll just use a B for brownie. So why don't we just go with mousse, apple pie, and brownies, and we'll end up making branches for those. And also, it's going to be a little challenging to squeeze the percents in here, but give us a minute and we'll finish that right up. Once again, through the magic of digital recording, we have finished our diagram, and you'll notice there are little weights. Everywhere we have our 22% for our chocolate mousses, we have our 0.46% on the apple branches, and we have our 0.32% for the brownies. Going back again, just to reiterate, all of those numbers would add up to be 1, so each little set of 3 branches totals 1.0 or 100%. When we're solving these problems, I don't usually look at the diagram. I look back at the little table that we have. So let's go into question B, the probability of someone ordering nachos, chicken strips, and a cookie. I don't think cookie was supposed to be on there. Cookie appears to be a misprint, so let's go ahead and call that a chocolate brownie. I think originally this might have been a chocolate cookie. So let's change that to a chocolate brownie, and let's go ahead and do some calculations. So, and I guess we could use a cookie, but then our probability would be 0, and that wouldn't make much sense. Alright, so nachos. When we look at the percentage associated with nachos, there are no nachos on our table either. Oh my goodness. Okay, somehow things didn't get changed whenever I did the printings, so we're just going to change up some of the questions. Since we don't have any nachos, let's Closest thing to nachos would be chips and queso. So let's change nachos to chips and queso. We do still have the chicken strips or chicken tenders, chicken, and then let's go with the brownie. So chips and queso would be 23% or 0.23. The chicken strips or the chicken tenders, that would be 38%. And then the brownie, which is what we're using right now, that would be 32%. So what we're going to do is multiply those three numbers together, the 0.23, 0.38, and 0.32. When we multiply, we get 0.027, or you could say 2.7% if you move the decimal over 2 places to make that in percent form. Alright, reading question C. What is the probability of choosing fried mozzarella? So we do actually have fried mozzarella. That would be a probability of 0.42. Fried mozzarella, a cheeseburger. We have cheeseburgers. So cheeseburgers are a 0.62. But then it says, and anything other than chocolate cake. Well, I guess that is pretty close to being a chocolate brownie. So let's go with a brownie again for this one. Despite this fact it says chocolate cake. We're going to go ahead and use the 0.32 for this. And again, we multiply all these things together. So 0.42 times 0.62 times 0.32, and we will get our probability. So after that multiplication, we get 0.083. If we change that to percent form, that would be 8.3% chance of getting fried mozzarella cheeseburger and a brownie for dinner. Alright, if we read the next question, what is the probability of choosing either nachos or fried mozzarella, chicken strips, and any dessert? Alright, so this time we're going to have to do a couple of things. So, nachos and fried mozzarella, let's go with the chips and queso, because that's almost a nacho. We're going to have to add that to the fried mozzarella. So there's going to be a little bit of work here first, and then we'll end up multiplying times our chicken strips, or chicken tenders, whatever, or eating chicken. And then we're going to take any of the desserts. So all of those are going in here. Alright, so let's write down some information. So chips and queso would be 0.23. Fried mozzarella sticks are 0.42. These need to be added. Depending on what kind of calculator you're using, you might go ahead and add these together right now before you do any multiplication. And you would get 0.65. Alright, so the chicken, that is a 0.38. And then all of the desserts, we've talked about this, if you add them all together, you get 1.0, or just 1. So we're going to end up multiplying 0.65 times 0.38 times 1 to get our next answer. So whenever we do that, we get 0.247. So that's going to be 24.7% chance of making that order. While I'm thinking about it, it's not listed on your paper, but sometimes you want to find out the probability of not ordering something. So I'm just going to take this example since we finished it and find the probability of not ordering chips and queso or fried mozzarella, chicken strips, or any dessert, kind of in that combination. So if I wanted to do the not probability, what I would have to do is the calculations you see here. So I would still go ahead and do all of this, and I would get down to this 0.247, or this 24.7%. And if I don't want to get that, I'm going to take my number and I'm going to do 1 minus 0.247. So I'm going to get rid of the chance that this actually happens. And when I do a little bit of subtraction, I find out that there's actually 0.753 or 75.3% chances that we do not order this meal. So Like I said, it wasn't on here, but sometimes you just want to know not. So in the case of finding something that's not an order, find the probability of that order first, like we did right here, and then go and subtract it from 1. We have just one more example here on our weighted tree diagram. So we're looking for the most popular combination and finding the probability of a customer choosing that. So what we're going to do is look at each section, appetizers, entrees, and desserts, and choose the menu item that has the highest probability. So in the appetizer column, the highest number is with fried mozzarella, and that is a 0.42. If you look at the entree column, people like their cheeseburgers. That's ordered 0.62 or 62% of the time. And then if you look at the desserts, apparently this place makes great apple pie. Apple pie is at a 0.46. So then that's the most popular combination. Fried mozzarella cheeseburgers and apple pie, and then you just multiply all those numbers together. And we'll see how often our favorite foods are ordered, and it's really not that frequently. Whenever you multiply this together, you get 0.119. That tells us that 11.9% of the time these three things are ordered together. And that concludes the weighted tree diagram portion of this lesson. If you flip the page over, now we're looking at Christopher's Auto Shop. Now, you may have seen this problem before, and that's okay, we'll talk about it again. Christopher's Auto Shop performs repairs on many types of vehicles. So, on the vehicles that they service, 80% are cars. So, we've got cars. And the rest are trucks. So, we're going to start making another tree diagram. We're going to have our two first options are going to be cars and trucks. If we know that 80% of these are cars, the rest of them have to be trucks. These must add up to be 100%, so you've got 80 cars and 20% trucks. Alright, so now of the repairs, of the car repairs, 25 are major repairs and the rest are minor. So those major repairs, they're not a whole lot of fun. Those are things like maybe your drivetrain falls off. I don't know, bad things happen with major repairs. So 25% of the car repairs are major, so then the rest of those have to be minor. That would be 75%. Right, trucks. For trucks, you have a 40% major repair percentage. So we're going to put a 0.40 there. And then you have minor repairs for trucks as well. So that's going to be 60 because 40 and 60 have to add up to be 100. Right, this is the end of that little tree diagram. There's some further information talking about profits, and we'll get to that whenever we get down to question number 4. Right, now this takes care of number 2. We've got our weighted tree diagram. All right, when you get to question 3, they start asking about major car repairs and the probability of having one of those happen. So, if we look at that, if it's a car repair, we're going to be taking the 80% right here, and if it's major, that's going to be 25% right there. And just like we did in our last problem, we're going to multiply 0.80 times 0.25, and that's going to be the probability of a major car repair. When you do that multiplication, 0.80 times 0.25 is equal to 0.20, so 20% of the time vehicles come in for a major car repair. The second thing we're looking for are minor car repairs. So we're still looking at cars. So our car repairs are still 0.80, but this time we're looking at the minor one. So that's 0.80 times 0.75. That ends up giving us a 0.6, or 60% of the time we have minor car repairs. Now we're going to move on down to the next section, major truck repairs. So when we look at trucks, that's only 20% of the company's business. But we have 40% being major repairs on trucks. So 0.20 times 0.40, that's going to give us a 0.08, or 8% of the time we have major truck repairs. And then the last category that we have, we're going to be doing minor truck repairs. So, again, we are still at point 20 for our truck section of the Venn diagram, or not Venn diagram, but weighted tree diagram. Apologize for that. So point 20 times point 60, multiply that together, and we end up with point 12. So 12% of the time, vehicles are coming to the shop for minor truck repairs. So whenever you're doing this, if you add up all the numbers that we've had so far, point 20, point 60, point 08, and point 12, we do end up with 100% of our business being represented. When we look at the next piece, question number 4, they say, how many minor car repairs will the auto shop perform in an average month? And how much profit will they make on these repairs? So the first thing we need to do is find out how many car repairs we're going to have that are minor. So we know that 60% of our business is minor car repairs. And if we go back to our paragraph at the top of the page, we find out we do 200 repairs a month. So what we need to do is multiply 0.6 times 200. And that tells us that we have approximately 120 repairs that are minor car repairs. We also need to do the same thing with the trucks. So we know that minor truck repairs take up 12% of our business. So let's multiply 12 times 200 and see what we get there. So 0.12 times 200, that's going to give us about 24 repairs per month. Alright, so this is good to know how many repairs there are. If we add that together, we have a total of 164 repairs that are minor. However, that is not the only part of the question. They ask us how much profit they will make on these repairs. So, what we're going to have to do is a little bit more multiplication. So for each minor car repair, our question tells us that they make about $50. So we're going to do 120 times 50, and that will tell us how much money the car business gives us. So that looks like that's about $6,000. If we look at the minor truck repairs, those are going to give us, let's see, an average profit of $80. So if we do 24 times 80, that's going to be about $1,920. If we add that together, we're going to end up earning off of major repairs about $7,920. The final part of our question, and problem number 5, what is the total profit the auto shop can expect to make each month on all of its repairs? So what we need to do now is find out the costs, or not the cost, but the profit that we're going to make off of all the major repairs. So we're doing the same type of process we did in number 4. We've got half this problem already finished. Let's go ahead and finish off the other piece. So, major car repairs. Those happen about 20% of the time. So we're going to do 0.20 and multiply that times 200. So that's going to end up being 40 different repairs. Can do the same thing for the trucks. The major truck repairs happen about 8% of the time, so 0.08 times 200, and that is going to leave us with about 16 of those. Now then what we'll need to do is find out the money involved. So for a major car repair, it looks like we earn about $300. So 40 times 300. And then for a major truck repair, it looks like those are going to earn us about $500. And we'll go ahead and multiply all those numbers out. So 40 times 300 gives us 12,000, and 16 times 500 gives us 8,000. If we add those two numbers together, 12,000 and 8,000, it ends up that this portion of our business gives us about $20,000. However, that's not all. What we need to do is take the $20,000 that we earned from major repairs, and we need to add that to the $7,920 that we get from minor repairs. So it looks like $27,920 is going to be our total for all of our repairs that we're going to do in a month. And that concludes our expected value portion of this presentation. take a minute to catch your breath, look over it, and then you are free to take your retest.